Welcome to October 14th LeetCode Challenge. Maximal score after applying k operations. You're given a zero-index integer array nums and an integer k. You have a starting score of 0. And one operation performs these following three tasks. Choose an index I such that I is greater than or equal to 0 and less than the length of nums array. 2. Increase your score by the index nums at index I. And lastly, replace the num at index I with the ceiling of the nums at index I divided by 3. Return the maximum possible score you can attain after applying exactly k operations. Do note that the ceiling function, taking in the val parameter of value, val, is the least integer greater than or equal to val. So basically, it rounds down. It rounds up. All right, let's do that. So let's take this example. You have an array of integer array of nums here, all value 10, and you have 5 operations you could do. So by applying this operation one time to each of the value, so 5 times, we get basically 50, where you take 10 plus 10 plus 10 plus 10 plus 10 equal to 50. That's pretty easy. Let's look at example 2. So in order for this to make sense, you want to maximize your score but if you want to maximize your score, you want to take the index with the largest value to be to perform the second step for your operation. So we look at this array here. We have 1, 10, 3, 3, 3. The largest value that would increase our score would be 10. So we would take that, select that value, index 1. So this is your index. We take that value, we add the score 10 to our 0 score, starting score. Then what we have to do is basically divide that by 3 and take the ceiling of it, which would be equal to 4. Then we have a new starting array here. Then we perform that again. So we have the largest value being 4. And we take that value of 4. Then we take the ceiling, divide by 3 of the index, which equal to 2. Then we would take the next largest value, which should be any of the 3's here. Then we do the ceiling value of 3, which is 1. So we take the values 10, 4, and 3. We have 17. That's pretty much the operation there. The constraints that the length of the nums array and k is between 1 to 10 to the 5, and each value of the index is between 1 to 10 to the 9. So how do you approach this? So in order to approach this, we want to use a priority queue to take the largest value within each of the array of each of the steps. So let's just kind of summarize this. We're given an integer array nums and a nums array nums and number k. The goal is to maximize the starting score from 0, performing exactly k operations. So we choose index. We probably want to choose the largest value with the index with the largest value. Increase the score by that nums at index I. Then we have to replace that index value with divided by 3, taking the ceiling of that. So we can solve this using a max heap, which allows us to access the largest element in the array efficiently. We need to be able to select the largest number, add it to the score, then replace it by the 1/3 of its value, doing this k times. First, we want to build the max heap for the numbers array. For each operation, we extract the largest number, add it to the score, and replace it with its 1/3 value, then push the score and push this new value back into the heap, replacing this k numbers of time to maximize the score. So in order to do that, let's first initialize our score. So let's call it a long value, and we're going to do score, and the initial score is 0. Then we want to create a priority queue, or a max heap, I should say. A max heap in Java will be a priority queue, which will do what we need to do. So the elements that we need, so the maximum the elements of each of the array. In order to do that, we use a priority queue here. Priority queue. It's got to take in an integer type, and we call it PQ for short. Then we do new priority queue. Then we're gonna pass it we're basically gonna order the priority queue because the order of the nums array doesn't really matter at the moment. All we want is the largest value on top. So in order to do that, we just do collections dot reverse order. This little trick there where we can take the largest value. And then now we have a priority queue with the largest value that we could access from one of the ends. All right. Next thing we want to do is we want to add each value to the priority queue. So we initialize the priority queue. Now we want to add each value that in our array nums. So for each int I in num, we're going to add to a priority queue at index I. All right, after that, while we have operations left, so it'll be k decremented greater than 0, we are going to add the max element in our score to score, and push its 1/3 value in a priority queue. So let's create a max element here. Oh, yep. And that is our max element is from our priority queue is going to be pull. We're going to pull it. All right, and then we want to increment our score by that maximum element. And then we want to add the 1/3 value of that max element, which is also taking the ceiling value of it as well. So to do that, we want to do max element divided by the float 3. All right, and then after that, while we exit this while loop, where we have no k operations left, we will want to return our score. If I have everything done correctly, this should run. Excellent, submit. There you go. Using a max heap, we're able to solve this. Not very good though, actually. Let me do some analysis on this. So time complexities wise, so initially we're starting with inserting all n elements into the max priority queue or max heap, which takes n log n times because we have n values to store inside the priority queue. And then after that, we have to take each of the k operations involve extracting the largest value from the priority queue and inserting a new value into it. Both of which takes log n, big of log n times, but we're performing this k times. So this part right here is k big O of k log n. So by adding this to this, the overall time complexity is big O of k log n plus n log n. Yeah, that's pretty much it. Space complexity wise, we're just dominated by the size of the heap or the priority queue, and priority queue has max n elements, so therefore space complexity is big O of n linear space. And that is it. Have a great day, everyone.